In this particular problem, we are trying to produce a box with the maximum volume. And it says it's a square base, so that means that these sides will be the same. We don't know exactly what the height will be. We'll just call it y. And we want the surface area to be 108. So I always start with an equation of whatever you're trying to maximize or minimize. So I want the volume equation. Volume of a box is base times length times width times height. In this case, it's x times y. And then it tells me that the surface area is 108 square inches. So surface area is all the areas added together. So I'll just look at this picture. So the area of the bottom of the box will be just x squared. Notice it said this one is going to have an open top. So we only have one. We don't need to worry about the top. One of the sides would just be xy, but you have 4 of them. So this is your surface area equation. Easiest to solve this for y. So I'm going to do 108 minus x squared divided by the 4x. Plug it in here. And now you have the equation in terms of one variable. Whatever you're trying to maximize or minimize, that's what you want to take the derivative of. So again, I'm going to have the calculator take the derivative of v, set it equal to 0, and find your intersection, and you should get x equals 6 is where that happens. And then it does ask for the dimensions, so you want to plug the x back into here to find the matching y. Okay, number 4. You're going to construct a box using a piece of cardboard paper that will allow you the most volume. Okay, so let me show you a picture of what you're doing. So you have basically a piece of paper, and what you're going to be doing is cutting out the corners. And it says you have a 40 by 40, so that means it's a square. So you started with 40 by 40. And we're going to cut out the corners though. So if you cut out the corners and you fold this box up, you'll get like a box if you fold up the pieces. And you're cutting out a square, so we're not sure what size to cut out, but each of those pieces will be x, right? So this little here is x that you're cutting out. We're trying to figure out what to cut out so we can make the biggest volume of this box. Okay, so again, let's think about the 2 equations we need. We need to find the maximum volume. That's what it's asking us to find. So I need a volume equation. Okay. If you think about this box that gets folded when you cut out these corners, notice the height of the box is going to be x, and then we need the length and the width. Notice you started with 40, but you're cutting out both of these pieces. So the length is 40 minus 2x. Same thing on this side, right? You had 40, but then you cut out both sides. So this is my volume equation in terms of one variable. You're going to use your calculator. So this is going to be your y1 equation. This will be your y2 equation. This will be your y3. We don't care about the y1 equation. We just need to know where the derivative is equal to 0. And it happens when x equals 6.6 repeating. But it does ask you to find the volume. So you would need to plug these back in.